Welcome to this tutorial on shell scripting basics. Today we're going to cover creating your first shell script and understanding execution permissions. Let's get started. So, what exactly is a shell script? At its core, a shell script is simply a text file. This file contains a series of commands that your computer's shell, such as bash, can understand and execute. Think of it like a mini program. These scripts are executed as a program, and they are incredibly useful for automating repetitive tasks. Instead of typing the same commands over and over again, you can put them in a script and run it with a single command. A shell script is all about combining multiple commands to achieve a specific goal. Look at the code snippet. The first line hashtag /bin/bash is called a shebang, which specifies the interpreter for the script, which is bash in this case. The next line is a comment and it starts with a hash symbol. The echo command displays the message, "Hello world," on the terminal. Finally, the pwd command prints the current working directory. Let's walk through the steps to create your first shell script. First, you need to create a file with its sh extension using a text editor. You can use any text editor you like, such as Nano, Vim, or even a graphical text editor. Next, add the shebang hashtag /bin/bash at the beginning of the file. This tells the system to use bash to execute the script. Then, write the shell commands you want to be executed in the script. The example on the slide shows how to create a file named misscript.sh using the touch command, and then opens it in the Nano editor. Inside the editor, we add the shebang, an echo command to print a message, and another echo command to print the current date using the date command within parentheses. Before we can run our script, we need to understand file permissions. In Linux and other Unix-like systems, file permissions determine who can read, write, and execute a file. As you can see in the table, the read permission allows you to view the content of the file. It is represented by the symbol R and the number 4. The write permission lets you modify the file. It is represented by W and the number 2. The execute permission allows you to run the file as a program, and it is represented by X and the number 1. The code box shows the output of the lsl command, which displays the permissions of the misscript.sh file. In the output, RWR indicates the file permissions. The first dash means it is a file, RW dash means the owner has read and write permissions, the next R means the group has read-only permissions, and the final R means others also have read-only permission. Notice that there is no execute permission set for the owner, group, or others, meaning the script is not executable yet. To make our script executable, we need to use the chmod command, which stands for change mode. The chmod command allows us to modify the permissions of a file. There are two ways to use it. We can use symbolic mode, where we specify who we want to change the permission for using the letters U for user, G for group, and O for others, and we can use the plus symbol to add a permission or the minus symbol to remove a permission. Alternatively, we can use numeric mode. We assign a number to each permission. Read is 4, write is 2, and execute is 1. Then we add these numbers together to set the desired permissions. A common value is 755, which gives the owner read, write, and execute permissions, and the group and others read and execute permissions. The code box shows how to use the chmod command to make the script executable, using both symbolic and numeric modes. It also shows how to verify the permissions using the lsl command. After running the chmod command, the output of lsl shows rwxrxrx, which means the owner has read, write, and execute permissions, and the group and others have read and execute permissions. Now that our script is executable, let's run it. There are several ways to run a shell script. The first way is to use the absolute path, which is the full path to the script from the root directory. The second way is to use the relative path. If you are in the same directory as the script, you can use // followed by the script name. The third way is to use the bash command followed by the script name. This tells bash to execute the script. The code box shows examples of each method and the expected output, which includes the message from the echo command and the current date. Let's look at a complete shell script example, which is named system_info.sh. This script displays system information, such as the host name, kernel version, and uptime. The script starts with a shebang, followed by comments explaining what the script does. It then uses the echo command to display a header, followed by the host name, kernel version, and uptime. The host name, unamr, and uptime p commands are enclosed in $ parentheses, which means their output will be substituted into the echo command. Now let's run the system_info.sh script and see the output. First, we need to make the script executable using the chmod plus x system_info.sh command. Then we can execute the script using the relative path /system_info.sh. The output shows the system information, including the host name, kernel version, and uptime. The script automatically fetches the current data, so the uptime will be the current uptime of your system. Let's discuss some best practices for writing shell scripts. First, add comments to your script to explain what each section does. This makes it easier to understand and maintain your script. Second, always include the correct interpreter path, or shebang, at the beginning of your script. This ensures that the script is executed with the correct shell. Third, include error checking to make your scripts more robust. This helps prevent unexpected behavior and makes your scripts more reliable. Fourth, store values in variables for better readability and maintenance. This makes your scripts easier to understand and modify. In this tutorial, we've learned how to create shell scripts with text editors, understand file permissions, make scripts executable with chmod, and run scripts using different methods. In summary, we covered 4 key points: creating shell scripts with text editors, understanding file permissions, making scripts executable with chmod, and running scripts using different methods. In the next tutorial, we'll cover variables, conditionals, and loops in shell scripts. Thanks for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.